Okay, so today we're going to look at double angle identities, last lesson in trig, woo! And then we'll also start looking at, or we'll look at solving equations while using identities. So these are your double angle identities. Again, they should be the last set of identities you see on the right-hand side of your formula sheet. So once again, make sure you have that formula sheet out. So we're going to start off with a proof. So prove that the identity 2 tan x over 1 plus tan squared x equals sine 2x. So a strategy I use a lot with identities is I'll use the quotient identity several times and also Pythagorean. So in this case, I'm going to keep the 2 tan x, but when I see that 1 plus tan squared x, if I go to my Pythagorean identities on my formula sheet, that is equivalent to secant squared x. So I'm going to go ahead and replace that with secant squared x. There we go. So I'm doing the left side. Make sure you split your paper up to left side and right side. Now that I've done this, let's use quotient identities. So I'm actually going to make that smaller. Tan is the same as sine over cos. And I'm dividing by secant squared x. Secant squared x is the same as 1 over cosine. That should still be a division statement. So now I can multiply the reciprocal. And I end up with cosine squared x over 1. I can cancel a cos x out of both the numerator and the denominator, and I'm left with 2 sine x cos x. Now, when you look at those identities that we just posted on the last slide, you can see that sine 2x is the same as 2 sine x cos x. So we have the same on the left side and the right side, so we have proved that the left side is equal to the right side. Okay, and then it's state non-permissible values. So anything that was in the denominator, we had cosine in our denominator, so cosine x cannot equal 0. All right, so again, on your unit circle, we know that cosine equals 0 at pi over 2 as well as 3 pi over 2. So to write a general statement, we would say our angle x cannot equal pi over 2 plus pi n, where n is any integer. So that would be my non-permissible value there. All right, so let's look at some double angle identities using those formula. So cos 10a. So we're going to go to our double angle identity for cosine. We know cos 2 theta equals cos squared theta minus sine squared theta. So what I'm going to do is I'm going to rewrite this. 10a is the same as 2 5a. So now you can see that angle is equal to 5a. So all I've done is written it in the same format. So I have my 2 and then my angle equals 5a. So now I'll use that right-hand side of the formula and I'll replace all my angles with 5a. There we go. Okay, and then tan x, this one's a little trickier. So if you look at your tan identity, and I'm going to erase this up here and write my tan identity, we know tan, 2x equals 2 tan x over 1 minus tan squared x. Okay, so here's the trick. I don't have a 2 there. But tan x is the same as tan 2 x over 2, right? So we can kind of write it still with that double angle identity, but we need the 2's to cancel out, so our angle is actually x over 2. Okay, so now that I know that, I can go ahead and use my identity on the right here. So I'm going to replace all of my angles with x over 2. There we go. Perfect. Okay. All right. Let's use the double angle identity a little more. So here, when we see this identity, the sine 4x cos x, that looks the same as sine 2 theta equals 2 sine theta cosine theta. So you can see your angle is the 4x. So then we have sine 2, our angle, which is 4x. And we can simplify that because 2 times 4x is 8x. There we go. All right, over here we have cos squared 1/2 a minus sine squared 1/2 a. Again, I'm looking at my double angle identities, and I notice that that looks very similar to the identity for cosine 2 theta, which is equal to cos squared theta minus sine squared theta. Okay. So my angle this time is 1/2 a. And once again, after I substituted that angle in, I can reduce or simplify this. 2 times 1/2 is just 1. So really, this is the same as cos A. Okay, last one. So this one you might be like, well, this looks really like the sine double angle identity, but it's missing the 2 in front. It is missing the 2 in front, but that's okay. We can still use it. So what we can do is 1/2 times 2 is just 1, right? So if you times something by 2 and times it by 1/2, really you're just timesing it by 1. Okay. So I have 1/2 2 sine 5/2x cos 5/2x. So now I'll use that identity. So I still have that 1/2 in front, but I'm going to have sine my double angle times the angle, which is 5/2x. The 2's cancel out here, so I'm just left with 1/2 sine 5x. There we go. Okay. So we're moving on to the next slide. So we'll do some of these, but not all of these. So what I'm going to do is I'll give you the solutions. And again, if you want to see the step-by-step process, feel free to go on to Moodle. Just time-wise, I won't go through every single one. So this one I will not go through. However, your angles should be 7 pi over 6 and 11 pi over 6. So if you want to try that one by yourself, those should be the angles that you're getting. Okay, this one I will do, okay, just to practice. So this, as soon as I see this, that's a sum and difference identity. So I should be going to my formula sheet and be looking at my sum and difference identities. So I know if I pull my formula sheet out, I'm just going to write it down for you. Cos A plus B equals cos A times cos B minus sine A times sine B. And then cos A minus B equals cos A cos B plus sine A sine B. Okay, so those are the identities that I'm going to be referring to. So now I'm going to have to write really small because I'm going to write this out. So I'm going to start with my sum identity for cosine. My first angle is x, my second angle is pi over 6. So I'm just going to write that out and replace everything. So I have cos, my first angle is x. Cos, my second angle is pi over 6. Minus, whoops, I wrote plus by accident. Minus sine, my first angle is x. Sine, my second angle is pi over 6. So all I've done is replace that with the identity. Now I'm going to need to use my difference identity. Okay, so we have cos, my first angle is x, my second angle is pi over 6, plus sine, my first angle is x, my second angle is pi over 6. There we go. So now if you distribute that negative, so So if I go ahead and distribute the negative, it's going to look like this. There we go. So then we're going to see that the cos x pi over 6 and this cos x pi over 6, they're going to cancel out, right? Because if you subtract two things that are exactly the same, they'll cancel. And then I have negative sine x and negative sine x pi over 6. So really, right, if you collect like terms, you'd have negative 2 sine x sine pi over 6 equals 1. So I'm going to go to my unit circle now and go to the angle pi over 6. And I will see on my unit circle that pi over 6 is equal, sine pi over 6 is equal to 1/2. So now I have negative 2 times 1/2 gives me negative 1. I can divide that negative 1 over, and I'm left with sine x equals negative 1. And then I can go to my unit circle. Where does sine x equal negative 1? It equals negative 1 at 3 pi over 2. So x equals 3 pi over 2 is my angle there. Okay. All right, so this one we will do because it has a double angle. So we're going to practice this one to work with double angles. Okay, so again, the first thing you're going to do, go to your formula sheet. Okay, so for double angles, there's a few choices for cosine. So you're going to use the choice that's going to help you the most with the question. So if I look here, I have a sine x on the left side. So really, if I have all sine x's, I can factor. So let's rewrite this so that we have all sine x's and then we can factor. So I know cos 2x equals 1 minus 2 sine squared x. So there's 3 different options for the double angle for cosine. I'm just going to use that option because it's going to help me the most with this question. So now that I've done that, I can just replace that cos 2x with that identity, which is 1 minus 2 sine squared x. Now I can rearrange this. So I'm going to bring everything to the left side so that I have a positive 2 sine squared x minus 7 sine x. And then I'll subtract that 1 over. 4 minus 1 is going to give me a positive 3. So from now, I can just factor. So let's substitute a in for sine x so that it's easier to factor. And I'm going to use decomposition. 2 times 3 is 6. Two numbers that multiply to give me positive 6 and adds give me negative 7, or negative 6 and negative 1. I will factor each half here. On the left side, I can factor out a 2a, which leaves me with a minus 3. On the right side, I can factor out a negative 1, which leaves me with a minus 3. So now I'm left with 2a minus 1 times a minus 3. So I can solve for that. So I end up with a equals 1/2 and a equals positive 3. So all I did was solve for those factors. And now I'll replace that a with sine x once again. Okay. So hopefully, and you're going to see lots, that's why with the unit circles so handy, is a lot of the questions are given. We end up with ratios on the unit circle. So this is on the unit circle. On your unit circle, you should find that sine x is equal to positive 1/2 at, let me see where it is, pi over 6 and 5 pi over 6. So I'm going to write a general solution for both of those. So my first general solution, pi over 6 plus 2 pi n, where n is any integer, and 5 pi over 6 plus 2 pi n, where n is any integer. If you were to try to find an angle here, you'd find there is no solution. So this is an extraneous solution, so I just say no solution. So my two general solutions are the ones that I found there. And this again is a perfect example of something really easy that you could double check on your graphing calculator. Graph this on the left side, graph this on the right side, set your domain to 0 to 2 pi or 360 if you want to work with angles, find your two principal angles, and then you can write general solutions. Okay, so we just did one with a double angle, but I think we'll actually do this one and then we'll skip the last one just to practice double angles. So this time we have a sine double angle. So I'm going to replace that with, I know sine 2 theta is the same as 2 sine theta cos theta. So all I'm doing is using that double angle identity to help me solve. So now that I've done that, this one's pretty easy to factor. I can just factor out a cos theta. And then I'm left with 2 sine theta minus 1. And then solve for each factor. So I have cosine theta equals 0 as my first factor, and 2 sine theta minus 1 equals 0 as my second factor. So I need to find all the angles where cosine equals 0. So if you look on your unit circle, cosine should equal 0 at pi over 2 as well as 3 pi over 2. It looks like we're dealing with degrees here, so let's rewrite that in degrees. So 90 degrees and 270 degrees. So 90 degrees, 270 degrees, those would be my principal angles. And then sine theta equals positive 1/2. Again, I'll use that unit circle. I know sine theta equals positive 1/2 at 30 degrees and 150. So those are my general solutions, or my principal angles. So now let's see if we can find a general solution. So let's check all the ones that the student have. 60 degrees plus 120. So that would give me 60 degrees, and then if I added 120, I'd have 180. So you can already see that I'm missing some of my angles here, so that's incorrect. Student 1 is wrong. Let's try student 2. So if I had 90 degrees and I added a full rotation, that would include the 90, so that's fine. And then if you had 30 degrees and you added 120 each time, what would my answers be? I'd have 30, 150, and then 30 plus 240 is 270. So there you go. Hey, there's all your solutions. There's the 90 in the first general solution and then the other 3. So student 2 is correct. Let's try student 3. So they're just increasing by 180 degrees. That's wrong, right? 180 degrees isn't even an answer here. So there's no way student 3 is right. Student 4, they have 90 degrees and then increasing by 180s. So I'd have 90 degrees. And then one rotation from 90 degrees, or 180 plus 90 degrees would give me 270. So that's good. Those are both solutions. Let's try the next one. 30 degrees. Yeah, that's good. That's a solution. 150 degrees. Yeah, that's a solution. So that also includes all 4 solutions. So student 2 and student 4 are correct, which means my correct answer is D. Okay, this is another diploma example. You can try it out. Actually, all of the steps are correct, right? They split up that 3 sine squared into 2 squared plus 1 squared. That's fine. It's just like breaking it up so that they could replace this with the identity, which equals 1. So that's fine. So actually, all of this work is fine until the solution, because we know sine equals 1/2, actually at 2 different angles, not just 1. So they forgot to include the 5 pi over 6. So that the arrow would be in step 6. Okay, that's it for today, and we will talk to you guys again soon.